A rare sky explosion is coming soon, a once in a lifetime event visible to the naked eye. Something in the next few months, a spectacle could light up the northern sky, and there in the Corona Borealis constellation, at a distance of more than 2,500 light years, a star called T Corona Borealis lurks, building up to an explosion that will temporarily cause the star to become one of the brightest objects in the night sky. Astronomers are on tenterhooks waiting for this thing to blow, not just because it will be amazing, but for the wealth of data we'll be able to collect on a type of star explosion called a classical nova. The reason we know T Corona Borealis, TCRB for short, is going to explode is because it has done so once every 80 years for at least 8 centuries. This means that it's very close to a once in a lifetime event, and that the technology we have to observe it now vastly outstrips what we had during its last excursion back in February 1946. There are few recurrent nova with very short cycles, but typically we don't often see a repeated outburst in a human lifetime, and rarely one so relatively close to our system, says astronomer Rebecca Hounsell of NASA's Goddard Space Flight Center. It's incredibly exciting to have this front row seat, she said. Not to be confused with the near obliteration of stars in the cataclysmic explosion known as supernova. Classical nova are smaller explosions that leave the star more or less intact. In fact, this is far from the first time this particular cosmic object has gone through this experience. The reasons TCRB explodes repeatedly and on schedule is a quirk of the type of star it is. It's a binary star system that contains the remnant collapsed core of a sun-like star called a white dwarf and a puffy red giant companion. White dwarfs are very small and very dense, between the size of Earth and the Moon, packed into the size as much mass as 1.4 suns. That means that they are pretty gravitationally intense, and if they have a binary companion in a close enough orbit, they tend to siphon off material, predominantly hydrogen. And over time, this hydrogen accumulates on the surface of the white dwarf, compressing down due to the gravitational pull. Eventually, the pressure and heat on the bottom layer of the hydrogen becomes so intense that the whole thing ignites in a runaway thermonuclear explosion that violently expels the excess hydrogen out into space in spectacular style. That's the nova. And for TCRB, the length of time this process takes place is about 80 years or so. Over the last decade, astronomers have observed the binary system exhibiting behavior similar to how it behaved leading up to the 1946 explosion, specifically a dip in brightness that heralds the close approach of the eruption. Their analysis suggests that this could occur very soon, as early as before September 2024. This means that astronomers are keeping a very close eye on a little patch of sky clustered with constellations, Lyra, Hercules, Bootes, and a little arc of stars sandwiched between them, and that's Corona Borealis. It's near Arcturus, by the way, between the Vega, Lyra, and Arcturus. Now we expect that we'll hear about the nova pretty much as soon as it happens. It will bloom in the sky to become visible to our naked eyes, then gradually fade from visibility over the course of a week. So you should have time to get out there and look at it if that strikes your fancy. In fact, you can, if you can, that would be amazing. Citizen scientists are being called upon to collect data too. The more eyes there are on TCRB, the better we'll be able to understand its flashy outbursts. And of course, there will be as many telescopes tuning in as can be arranged, from the longest radio wavelengths to the most powerful X and gamma radiation. Recurrent nova are unpredictable and contrarian, says astrophysicist Koji Mukai of NASA's Goddard. He said, when you think there can't possibly be a reason they follow a certain set pattern, they do. And as soon as you start to rely on them repeating the same pattern, they deviate from it completely. We'll see how TCRB behaves. And this is on Science Alert by Michelle Starr. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.